the last thing we need to do is bridge the gap between bounded deductions and bounded cut-free deductions. We're going to show that we can take a bounded deduction and transform it into a cut-free one. And to do that, we'll need intermediate steps. When we have a cut rule, it looks like this. The formulas phi and negation phi are called the main formula or the cut formula, and they have the same rank. We're going to write z infinity deduces gamma with bound alpha k on top and a rank c on the bottom to mean that there is a deduction of gamma with bounds alpha k, so that in this deduction, the cut formula in every cut rule has rank strictly less than c. In particular, when we have a 0 on the bottom, we're talking about cut-free deductions. When there's a 0 on the bottom, every cut formula should have rank less than 0. But no formula has rank less than 0, so there are no cut formulas, so the deduction is cut-free. If, for example, we have a 1 on the bottom, that means every cut rule has a cut formula with rank less than 1. The only rank less than 1 is 0, so the only cuts are atomic or negated atomic formulas. A deduction could, in theory, have infinite cut rank. Z infinity allows deductions with infinitely many branches, which might have more and more complicated cuts. These don't happen naturally. In particular, they don't happen in the deductions we care about, the ones where we took a proof from PA+ and converted it to Z infinity. So there's a slight strengthening of our lemma from the previous video. If we can prove a sentence phi from the axioms PA+, we can deduce phi in Z infinity with bounds alpha comma k and cut rank a natural number c with alpha less than epsilon 0. That doesn't follow for free from the lemma. It follows from the proof. If you go back and look carefully through the proof that these deductions are in Z infinity, you notice that there's a bound on the ranks of the cuts we used in that proof. So in the next video, we'll show how to take one of these deductions with cut rank greater than 0 and reduce the rank of the cuts. Show how we transform it ultimately into a cut-free proof.